All right, today we're going to be learning about slope. We should be on page 378 in our books. Looks like everyone's there. All right, so the first thing that I want to teach you about slope is how to recognize whether it's positive or negative from the beginning. So I've got, let's say, this, got this. All right, so I have 3 lines on 3 different graphs. Now, it's important, now we're looking at the top left one first, okay? We always read these left to right, okay? So we always start at, let's say that I've got, and we're not worried about the actual coordinates of the point, but I've got, points on each one of these lines. So I always start at the point furthest to the left, okay? So this point right here is the point that I start at. Now, if my line goes down, okay, from that first point, I know that my slope is negative. Again, I start reading each one of these from the point furthest to the left. Well, on the second graph, my line goes up. So this would be a positive slope. All right, and then if it's a horizontal line, my slope is 0. Okay, so the first questions on your homework tonight deal with this. You don't have to redraw the graph. All you have to say is positive, negative, or 0. And you always do that by reading it left to right. If it goes up, left to right, then you know it's positive. If it goes down, you know it's negative. If it's straight across, you know it's 0. All right? Pretty straightforward? Okay. So the next thing, and this is the first thing that you need to write in your notes, is the slope formula. Okay? Now, this is between 2 coordinates on a line. Okay? So we just, talked about 2 points on a line. So between those 2 points, we're looking for the rise over the run. And I also want you to write this in your notes. The change. Now, what do you think rise is? Rise. Do you think that that's going to be X or Y? Up and down. Rise. It's going to be your Y, right? Because it's the up and down value. All right. And then run is going to be your X. So it's going to be the change in Y over the change in X between 2 points. And you'll see more what I'm talking about here in a minute. Okay, so I just want you to write that in your notes. Slope is rise over the run. We're looking for the change in Y divided by the change in X. All right, so now I'm going to use that formula to find the slope of a line. So now we're going to go over to your graph paper. Okay, go over to your graph paper and we're going to set up a few graphs. All right, so you don't have to set up the negatives. All right, this is going to be the first part of example 1. All right, so I just want you to set up the positive, both positive axis, the sides of the axis. This is example 1. All right, so now I have 2 points on the graph. I have 1 point at 1, 2. Okay, so please plot that point on your graph. 1 point at coordinate 1, 2. And then another point at coordinate 5, 4. And then draw the line straight through those points. Okay, so one of them's at 1, 2. The other one is at 5, 4. Okay, now in order to find the slope, okay, what did I say the formula was? It's rise over run, right? Now, if I'm reading it left to right, which one is the first point that I'm going to start at? 1, 2, right? I'm going to start at that point right there. So I want to look at the change in the rise between the 2 points. So I'm going to go up from point 2, and then what's the Y value for the second point? What's the Y value on the second point? It's at 4, so I went from a 2 to a 4, right? The change in the rise was 2 units. What about the change in the run? I went from an x value of 1 to an x value of 5. So what's the run? The rise is 2 and the run is 4. From 1 to 5, that would be 4 units. So rise over run would be 2 over 4. Now, anytime you have a fraction that can be reduced, you want to go ahead and reduce it. All right, so I would say that my slope is 1/2. Okay, so again, it's rise over run. Rise over run, so my slope is 1/2. All right, so now let's do another one. If you haven't already and you still can, make sure you fold your graph paper because we're actually going to do 4 graphs today, so it would work out really nicely. If not, that's fine. You can just use the back of your graph paper. All right, so on B, here's how I want you to number B. You need a few negatives, okay? So go ahead and number these. And then we're going to do another one. Okay, so now my points are at -1, 2, and 2, -1. So go ahead and plot those points and draw a line through it. Okay? They're at -1, 2, and 2, -1. All right, so what do you notice that's different right off the bat from the first one? What is different about this line compared to the one from example A? Zach? The line is going in the opposite direction. And what did I just tell you about a line that slants down to the right? That slope will be negative. Very good. So now I'm still looking for the change in the rise. And I still start with the point that's furthest to the left. Okay? So I still start with a point at -1 up 2. Now, what is the change in y? I go from a +2 to a negative what? -1. I go from a 2. The first point is on 2. The second point is on the -1. Do you see that? Sebastian, do you see that? Okay. So I count. What is my change in the rise, in my y? Well, I go down 1, 2, 3. -3. Okay, because I went down. All right? So anytime you have a negative slope, the rise is going to be negative, not the run. The run will never be negative. The rise will.
I thought you went across.
No, you always do rise first. Okay? Then, what is your change in the run? You go from a -1 to a what?
3.
To a positive
2.
2. So, how many units is that, Hazen?
3.
It's 3. Okay? So, what is my slope? -3, so my rise over run. My rise is -3. My run is 3. So what is my slope? Can I simplify that fraction? To -1. My slope is -1. Slope is -1. Okay? All right, so it's always rise over run. If the y values are decreasing, going down, all right, meaning that the line is sloping down to the right, make sure that you make that slope negative. Okay? All right, that's it for example 1. Now in example 2, I'm not going to draw this one. I'm not going to make you draw it, but I do need you to look with me on page 379. All right, in example 2, I'm combining what we're learning today with what we learned yesterday. What did we learn yesterday? We learned about what?
Ratios.
Not ratios. That was 8.1. What did we learn about? We learned about rates and unit rate, right? So in example 2, it says, find the speed of the lava flow, and in order to find it, you need to find the slope. All right, well, what's the formula for slope? What's the formula for slope? Rise over run. Okay, and on that line, it gives me a coordinate, 4, 6. Well, how would I write that as rise over run? The rise is the y value. So what would my fraction be? Alicia? 6 over 4, rise over run. My rise is my y, my run is my x. So I would write that 6 miles in 4 hours. Okay? Now, how would I find the unit rate?
Oh.
Chris?
You divide 4.
Very good. Divide top and bottom by whatever number is in my denominator, and I get 1.5 miles per hour. So I used a coordinate on my graph to write my slope, and then I divided top and bottom by 4 in order to find the distance per hour. Okay? All right. That's it for example 2. Does everybody have that down? Okay. Now moving on to example 3. In example 3, we are looking at using slope to draw a line. Okay? So you need to go ahead and set up your graph. We're going to do 2 more. All right, and example 3a says that my slope is -3 and the line passes through points 2, 5. Okay, so set up your graph, and we're going to use this information to draw a line on the graph. All right, so what do you think is going to be the first thing that you want to do? What's the first thing you want to do in graphing this line? You want to plot the point, right? Plot the point at 2, 5. So go ahead and plot your point at 2, 5. But now the question is, how do I figure out where my next point goes? All right, well, it tells me that the slope is -3. But I thought that the slope had to be rise over run, right? Well, this isn't a fraction. So what do I do? How do I know what my run is? Hazen?
You go down 3 because it's
Okay, I know that, but how do I know what my run is? It's not a fraction. Or is it? Can I make a whole number a fraction?
Yes.
By doing what? Putting it
Putting it
over 1. Very good. So I can make it -3 over 1. Now I have my rise and my run. Okay? So anytime you have a slope that's a whole number, just know that it's automatically over 1. Okay? And then if you have a slope that's a fraction, well, you know exactly what the rise and the run are. But if it's a whole number, know that it's over 1. So, just like Hazen just said, my rise is what? My rise is -3, so I need to go down 3 from that point. 1, 2, 3, and over how many?
1.
Over 1, and I plot my point. Okay? Then I could do it again. Now on your homework, you only have to have 2 points, but just in case that confused you, I'm about to do it again. I go down 3 again and over 1, and I can plot another point. Then I can draw my line through it, and I've graphed my line. Okay? So plot the initial point and then use your slope to figure out where your next point goes. Okay, now on to B. So now I have the points -1, -3, and 3, -4. Go ahead and set up your graphs, and if you happen to get done before I start going over it, try to graph this line and tell me what the slope is. So the instructions will say, draw a graph of the line that passes through these 2 points, and then tell me the slope of the line. Okay, so let's get started on that. All right, so I plot the points at -1 down 3 and 3 down 4. What do I know right away? I know that my slope is negative because it's going down to the right. All right, so what's my change in the rise? What's my change in the rise?
One.
-1.
Oh, yeah, that's right.
What's my change in the run?
4.
4. So my slope is -1 over 4. All right? If you understand that, that's everything you need to know for 8.3.